Hello everyone and welcome to the next video of the Cloud That Smart Desk series. And in this video we are going to learn about the Smart Scale feature. So the Smart Scale feature is completely dependent on the ultrasonic sensor, and there is some customized arrangement what we have made here. This is an extensible cord which we basically used in our telephones. And with that, we have connected our ultrasonic sensor. So we are going to interface this sensor in this project. So let's talk about the components what we have at this point of time. So we have the Arduino Nano, which we are using as a microcontroller. We have a power supply, the breadboard power supply. We have the breadboard to integrate all the components. We have the USB type B cable because this is needed for giving power to the USB cable, giving power to the Arduino and also to upload the code in the Arduino. And as I just mentioned, we have an ultrasonic sensor. We also have this 12-volt DC power supply which is used to give power to the breadboard power supply, which ultimately gives power to all the components. So now let's check out how we are going to interface these components together. So as usual, the first component what we will connect is a breadboard power supply, and we'll fix the breadboard power supply like this, leaving some gap on the extreme side. After that, we are going to connect the Arduino Nano exactly like this, where the USB pin is facing exactly opposite to the breadboard power supply. And the third thing what we are going to interface is the ultrasonic sensor. As I said, this is a custom arrangement what we have made because this is a part of your product. And as we know that the ultrasonic sensor works on a specific scientific principle, right? One of the unit is going to transmit the ultrasonic sound waves and another one is going to receive those sound waves, and based on the difference in time it is going to calculate the distance at which an obstacle or an object exists. So we are going to interface this sensor. As usual, for the power we are going to use the power lines that is on the breadboard power supply, which is given on the extreme corners of this breadboard, right? And we are going to have the two pins this time for data, because one is for the trigger which is going to transmit the waves and another one is echo which is going to receive the waves. Now for the interfacing, we can check the flip side of this sensor and we can see that there are 4 pins. The VCC pin will be connected to the positive terminal of the breadboard power supply. The ground will be connected to the negative terminal or the negative voltage line of the breadboard power supply. The echo will be connected to D12 and the trigger will be connected to D11. So let's interface this. So for this, first we need to check the color coding. So VCC is blue in this case. So we'll take the blue pin, the blue cable, and connect it to the positive side of the breadboard power supply. After that, we have trigger, which is the green button, the green cable, which is going to be connected to D11. So let's connect this to D11. If you think that there is a problem with the spacing, you can shift this anytime to the pin which is closer to you, like this. The echo is the maroon cable over here, and that is going to be connected to D12. So let's connect the pin here. And finally, there is a ground pin which will be interfaced on the negative voltage power line, right? So now we have this sensor which you can move, and I will show you how we are going to use this sensor exactly when in the last video. Basically, I will show you how to use it, but this is the way you are going to interface this sensor. So now we'll connect this setup to the computer because we need to load our code which we have provided. So in the last videos with Arduino, I have already shown you how exactly you are going to give the power to the Arduino board from the breadboard power supply. So I'm not repeating the same steps. And as usual, after every activity, we need to add a code. So again, this time I'm going to use the same USB type B cable, which I'm going to connect to the Arduino board. And I'll connect the another end to the laptop. All right. So now let's check out what kind of code modifications we need to do, and then we'll upload our code for the ultrasonic sensor in the Arduino board. Now I have already connected my Arduino board with the laptop machine. So let me check the user manual. Now, if you can see here, we have provided a link to download the library, and this library also contains the code for the ultrasonic sensor to work. So I will just click on this link and I will go to this page. Here we can find out that there are a couple of files which are listed here. In this case, we will need NewPing version 1.8. So I will click on that and the zip file will be downloaded to my machine. Now I will extract this file to the Arduino library folder. So for that, I will go to Documents. Inside Documents, there is a folder called Arduino, and inside there we have the folder called Libraries, and this is where we will like to extract the library. So I'll just click on OK. Okay, so now the library is extracted in the Libraries folder of Arduino. So now let me access the Arduino IDE. Now we'll go to File, and inside File we'll click on Examples. Now we'll scroll down and we can see that there is an example called NewPing which is available. This option, or rather this library, is existing here because we just extracted our content to the Arduino library folder. Now from this we need to select the NewPing example because this is the actual code which is going to run the ultrasonic sensor live. So I'll click on this, and before I can go ahead and upload this code, I will click on Tools and I will change the board to Arduino Nano because that is what we are using. Now as you can see here, we have changes to Arduino Nano. We can also click on Tools and see if we have a COM port. Yes, we have a COM port 4 which is provided by the system. We will just select that COM port so that it can be utilized. And now I will just upload the code. So the sketch is getting compiled. Okay, so it shows that the uploading is completed. So now to check if the sensor is working with the board, I'll click on serial monitor. Okay, now here basically we should get the output in terms of some distance which is detected by the sensor, but we are getting this kind of random data because the baud rate is not right. So in this case, I will select the baud rate as 1,15,200 and perfect. Now we can see that the sensor is defining the distance in terms of centimeter. Now as and when I move my ultrasonic sensor, the distance from the closest object is shown here. So as you can see, it's 3 centimeter. Now I'm taking up the sensor to a new height and it's 21 centimeter. So yes. So yep, in this way we verify that the sensor is working perfectly fine, and that's all we wanted to perform in this video. So thank you, and we'll connect in the next video.